Okay, this is going to be a quick review of variation for those of you who've studied this a little bit before, with just a couple examples of variation and how we can combine variation. Variation, again, is a fairly simple idea in algebra. There's really three major types. So we've got direct variation up here, y equals k times x. We've got inverse variation, y equals k divided by x. And then joint variation, which is kind of like double direct. It's z equals k times x and y. So you're sort of doing a double multiplication there. The real different one is that inverse in the middle, where again, it essentially means we're dividing. If we're directly or we're jointly directly multiplying, inverse sort of is doing the opposite. It's dividing it away. So a couple quick examples for you. Down here at the bottom, we know that the simple interest for a certain savings account is jointly proportional. Proportional, just another way of saying varies. So jointly proportional to the time in years and the principal in dollars. After 1 quarter or 3 months, the interest in the principal interest on the principal of $5,000 is going to be $43.75. They want us to write an equation relating interest, principal, and time. Now notice they didn't mention that k value. Again, that's what we call the constant of variation or the constant of proportionality. The first thing we need to do is figure out what that is in order to go do more information or to get a good equation relating just the interest, the principal, and the time. So I'm going to start off writing an equation very simply that's going to say the simple interest will be equal to, and again, it's jointly proportional. So I'm going to throw k in here because we do have to have that k value, that constant of proportionality, that constant of variation. We also need to relate it jointly to the time in years. So we'll call that t, and the principal, we'll call it p. Well, if we plug in the stuff that we know down here in the space that we have provided, we know that the interest will be $43.75. We don't know the constant yet, but we do know that the time was 1/4 of the year, because we want to talk in yearly or annual interest. And the interest on that principal, the principal was $5,000. So very simply, again, 1/4 of 5,000 is going to be 1,250. And if we divide that away, right, divide both sides by 1250, then k will come out equal to, so 43.75 divided by 1250, 0.035. And for those of you familiar with simple interest, basically what we just found was the interest rate, right? The rate at which, right, the principal times the time, rate times principal times time is the formula for simple interest. We just figured out we're earning about 3.5% simple interest. But now let's finish this problem off. Remember, we wanted to write an equation relating those things. So S equals 0.035 TP. Again, that would be my equation. That's what we're really looking for. When they say write an equation relating those three things, again, we need to fill in the k value. They didn't say relating the constant as well. We have to have the constant filled in. Then we can go use our equation, find the interest after 3/4. Well, now very simply, we've got our equation. We know the interest rate. We know that 3/4 is our time. And again, since we didn't mention changing the principal, we'll assume they mean let's keep that principal the same. And again, if we take 0.035 times 3/4 times $5,000, we are going to end up with $131.25 in interest. Let's take another look at a quick example here. This one might take us a little longer on the calculating, so bear with me here. But the gas law states that the volume of an enclosed gas varies directly as the temperature and inversely as the pressure. So we're going to get a little bit more complex here. So the volume, at first thought, is going to vary directly as the temperature. So again, get that constant in there. varying directly as the temperature, and at the same time. Now we don't need a new constant because we don't know what the constant is yet. So whatever number we're throwing in there is multiplied and being divided. We can get away with one thing, but and being divided or inversely as the pressure. So again, to write our equation, we can take advantage of that. The pressure, they're telling me, is going to be 0.75 when the temperature was 294 Kelvin. And again, bad choice of variables here. I'm actually going to change this K to an A just because we don't want to confuse it with that K from Kelvin. So we're going to say 294A up here. Again, it's just a constant. Doesn't matter what variable we use. And again, that's going to be equal to the volume, or 8,000 cubic centimeters. Well, for a simple little solve, again, we need to multiply our 0.75 over to the other side times 8,000. And at the same time, since we'd be left with 294A, let's divide away the 294. That should leave us with A. So we should be able to find our constant that way. So again, 0.75 times 8,000 divided by 294. We get a kind of a complex decimal there, so I'm going to go ahead and make that into a simple fraction, 1,000 over 49. So to keep it exact, so we get a little better number, we're going to call that 1,000 over 49, which means our equation then was volume equals 1,000 over 49, technically times T, and again divided by P. If you want to throw that all together as one big fraction, you can definitely do that. Either way works. But again, there's going to be our equation. So that now we can go over here to the right and say, okay, find the pressure. Now they weren't asking for the volume, so they're going to be a little bit more careful here. But we're going to find the pressure. So find P. Let's go ahead and say 1,000 over 49. We're looking for P here. When the temp is 300, so again, I can fill that in, and the volume is 7,000. So let's just kind of take a good look at what we want to do. Again, with that P value in the denominator, I would go ahead and multiply that over to the other side. So let's call this 7,000 P equal to 1,000. And again, you could find those numbers if you want to. Times 300 over 49. And while we're at it, we can just divide away the 7,000. So our pressure will be equal to 1,000 times 300. Again, when you divide a fraction, you're really multiplying into the denominator. So 49 times 7,000. And we'll figure out our pressure here. So again, 1,000 divided by 7,000, we could really get rid of those zeros. So that'll save me some typing. All right. So 300 divided by 49 times 7 is really what we're looking for. 300 divided by 49 times 7. And it looks like our pressure will be 0.875 approximately. That is rounded off, right? Approximately. And again, the pressure was being measured in kilograms per square centimeter. So again, that's going to be our answer on there. I hope that gives you an idea how to use joint variation as well as direct and inverse variations, and if they're combined, how to use them together as well. If you have any questions, make sure to talk to your teacher. Otherwise, have a great day.